Hi, welcome. Today's lesson is graphing. We're going to start with the function y equals f of x and figure out how to graph the function f prime of x. Note, this may be the first time I've mentioned f prime of x is a function because, well, you put numbers in, you get things out. What are these numbers? They're the slopes of the original function, but it's a function. Now, I also want to do it backwards, which is trickier. This is all going to be done with pen rather than precision. I'm not going to use formulas. I'm going to try to look at the graph and see how the graph tells me about the other graph. So here's a graph of a function. This is in black, it's y equals f of x. So I need to draw the derivative. What is the derivative again? It's the slope. It's the tangent slope. So let's take a look using our handy-dandy slope detector. And the slope is there. Now I don't know exactly what that slope is. We can figure out more precisely. But right now I'm going to say that's positive. Positive slope, positive slope, positive, 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 zero. It's zero right there. And that's probably the most interesting point right now. I'm going to find out where the slope is zero. Right there. Right at the top. Why the top? Because right before the top it's going up, after the top it's going down. So right at the top, that's where it's flat. What is that? That's about right there. So where else is it flat? Well, actually, basically all of that. From about here to about here. Where else is it flat? Anywhere? It flattens out right about here. And it says it goes straight. So those are our points where the derivative is zero. Now notice, this is an interval of 0, that's an interval of 0, so those aren't that interesting. But this point where the derivative is 0 corresponds to a maximum. When you have an isolated point that's derivative is 0, it's going to be a maximum or maybe a minimum. That's typical. It's not always the case, but it's something to think about how they're associated. Now as I said, the derivative is positive here. What is it here? It's negative. Then it's positive. So we're going to be above the axis here, below in here, and above right there. So now let's try to figure it out. If you have a good scale or graph paper, you can actually do this. Otherwise, you have to sort of estimate and guess. But right here, I have that slope. So let's think about that. What is that? That's about 1. Just because, look, that slope goes right about there, from here to there. The rise over the run is about 1. That's an estimate. It's an eyeball estimate. But that's about what it is right here. Why am I putting it there? Because that's the slope number of 1. 1 up means a slope of 1. Now, it stays that way until it gets a little flatter, until eventually it goes nothing. So it's staying pretty flat until it slopes down, and it slopes down until it has almost no slope. Notice the red. The red is a different graph than the black one. The slope here is almost 0. So the red line is almost at 0. Likewise, how steep does it ever get? It gets that steep. Now what is that? That's probably about a 2, but it's negative. So at some point it gets down as steep as about -2. And then it kind of flattens out, and eventually comes back up. These are estimates. It's about 1 there. So maybe actually it goes up faster than that. And here, that's a slope of about, honestly, about a half, I think. So it's going about a half and then back. That's sort of how you do it. Hopefully it's reasonably clear that the slope is positive over here, negative here, and positive there, and it's 0 in those two intervals and that point. The exact steepness, we can worry about that. Okay, so that's drawing y equals f prime of x from y equals f of x. How about if we go backwards? So let's do that. Here's a new graph. In red is the derivative, so I want to try to draw the original. But there is an actual snag in this. So this is the slopes of the original graph. This is the slopes. It's not the original points. So we know right here, That's 1. So it looks like that's flat, right? But that's the slope of the slope. What we want is the original graph. Excuse me. So, right there we know the original graph has a steepness, has a slope of about 1. But where does it start? And here's the thing, it could start anywhere. It could have any y-intercept we want. So we have to be careful. We just choose one. But we have to be careful what we're doing. I'm going to choose a y-intercept here. Why? Because it's a good place to start. Anyway, right there, that's 1. So we've got a slope of about 1. Right about there. Now what about here? The slope, it flattens out here. So it's going to get bigger. It's going to get bigger until it flattens out. What happens here? Now, the red is below the x-axis. The red is the slopes. So if we're below the x-axis, we're in the negatives. The slope is negative here. It's coming down. And eventually is at -1. So eventually, and actually pretty quickly, it gets to a slope of -1. It stays that way more or less. That's how you do it. That's half our graph. Let's try it. Let's try the other half. Think about it. What's going to happen? Well, these are all positives. I don't want the slope of red. The red is the slopes. No slope there, getting to be steep. So if it's not steep there, and it is steeper. So we're probably going to have something like this. Notice what happened on this side, then it curved back down. Why? Because we crossed the axis. But look over here. This is above the x-axis. So this represents positive slopes. What does a positive slope look like? Like this. So we're going to have something like this. And then it's going to a rate of about 1 there. Then it flattens out to 0 right there. And now these are negative numbers, negative slopes. Negative slopes are like this. So it's going to do this. Remember what I said? That where the derivative is 0 was like mins and maxes? Well, let's look at that. Where the derivative is 0, we have a max. Where the derivative is 0, we have a min. Now here, where the derivative is 0, we have another point. So, where the derivative is 0, we could have a max or a min, sometimes something else. Hopefully this gives you at least an idea how to draw. Give it a try. Until next time, this is Dr. Joe.